Okay, Assalamualaikum and good day. So, in this video, we will take a look at even and odd functions. Okay, so a function fx is called an even function if f negative x is equal to fx, and a function is called an odd function if f negative x is equal to negative fx. Okay, for example, let's say we have fx equal to x squared. That means f negative x is equal to negative x squared. Negative square will be positive, so x squared is x squared. So here we have f negative x is equal to fx. Since f negative x is equal to fx, that means therefore fx is an even function. Okay, the next thing, fx is equal to cos x. Okay, so f negative x is equal to cos negative x. Okay, which is the same as cos x. Take note what we have known earlier. Cos negative pi is the same as cos negative and pi. That's why here cos negative x is equal to cos x. Okay, so right now the same goes here. F negative x is equal to fx. Therefore fx here is an even function. Okay, so right now fx, for any fx x equal to n, where n are even integers, it is also an even function. Why? Because let's say we have here f negative x, it is equal to negative x power of n. Okay, power of n. So since n is even integer, so we will still get x power of n, because negative power of even is equal to positive. Okay, since f negative x equal to fx, therefore fx is an even function. Okay, so next for odd functions. So let me do a bit of highlight here so that you know that this is the part for odd function. This is the part for even function. Okay, so next. Okay, we have fx equal to x. And when we substitute f negative x, we have negative x, which is the same as negative fx. That means here fx is equal to negative of fx. Okay, therefore fx here is an odd function. Okay, the same here, fx equal to x cubed. F negative x is equal to negative x power of 3, which is negative power of odd would be negative back. Okay, x cubed, which is the same as fx is equal to negative fx. So we can write the same conclusion here. Okay, fx is an odd function. Okay, the same goes here with fx equal to x power of n. Okay, that means here we have f negative x is equal to negative x power of n. Negative power of odd would be negative, and x power of n is negative x power of n. F negative x is equal to negative fx. So therefore we come to the same conclusion again. Okay, that fx is an odd function. The same goes for s sine x. Why is it an odd function? Remember, sine and pi, okay, this should be pi, is equal to negative sine and pi. Sorry, negative and pi. This is what we have known from the previous topic. So that's why here fx equal to sine x. So f negative x is equal to negative sine x, which is f negative x is equal to negative of fx. So therefore fx here is an odd function. Okay, graphically, the graph of an even function is symmetry with respect to the y-axis. Okay, symmetry for even function, it is symmetry with respect to the y-axis. Okay, and then the graph for an odd function here possesses symmetry with respect to the origin. Okay, let me show you an example. Let's say we have here fx equal to x. So how do we graph it? Okay, this should be the axis x and y. So this is the function. Let's say this is 1 and this is negative 1. So as you can see, for f1, the value is 1. F negative 1, the value is negative 1. And it is symmetry at, with respect to origin. That means if we do it like this, okay, let me search for the ruler. Okay, here we will be using the ruler. It should be 45 degree. Consider. Okay, here, if I make a straight line here, okay, so that means it is symmetry at origin. Okay, when for 1 it is 1, negative 1 should be negative 1. Let's say for half, for 0.5 it should be positive 0.5. For negative 0.5 it will be negative 0.5. And then next, let me show you an example for this one, fx equal to x squared. Okay, let's say we have fx, sorry, the pen is in red, so let's change it to blue back. So, okay, fx equal to x squared. Here we have the axis, the graph should be like this. Okay, so that means here, let's say we have here is 2. So here is 4. So here is negative 2. As you can see, when x equal to 2, y is equal to 4. When x equal to negative 2, y is also equal to 4. That means it's symmetry at the y-axis. Okay, it's symmetry here. Okay, 90 degree. Okay, a bit more. Okay, here. Should be straight actually, sorry. Okay, done. So that means here it is symmetry at the y-axis. Okay, imagine that is the straight line that I draw earlier. Okay, so here it's symmetry at the y-axis. This one is for even function. Let me stress it again. Symmetry at the origin will be odd. Okay, symmetry at origin. Okay, and then here is even, since it is symmetry at y-axis. Okay, so right now let us look at here the theorem 3.1, properties of even and odd functions. So here what we have is for a, the product of two even functions is even, because you can just imagine the even function is a positive. So positive times positive will be positive. Okay. So next, the product of two odd functions is also even. Why? Imagine odd function is negative sign. So negative times negative will be positive. That's why two odd functions will be even function. The product of an even function and an odd function is odd. Why? Imagine positive times negative. It will be negative. Okay. Maybe I should write it. Positive times positive. So it is positive. Negative times negative. So it is equal to positive. And here positive times negative, it should be negative. Okay. Okay, next will be this one. The sum difference of two even functions is even. Okay. And also we have here the sum difference of two odd functions is odd. Okay. Okay, next, if f is even here, f is even, then integrate from negative a to a fx dx is equal to integrate 0 to a fx with respect to x. Okay, and if f is odd, then integrate negative a to a fx with respect to x equal to 0. A quick example, let's say for even, we will use x squared. So integrate from negative 1 to 1, x squared with respect to x is equal to x cubed over 3. We need to substitute negative 1 to 1, which is 1 over 3 minus 1 over 3. Okay, because negative 1 power of 3 is negative 1. Okay, here we have 2 over 3. Okay, let's say we integrate from 0 to 1, x squared with respect to x. We have x cubed over 3. From 0 to 1, we will have the value is actually 1 over 3. That's why here, integrate fx from negative a to a with respect to x is equal to 2 times this. Okay? That means 2 times of 1 over 3. Okay? And next. Wait a second, sorry. Okay, so right now, the arrow should be this way. Okay. And then next, if f is odd, then we have 0, right? For example, let's say we integrate from negative 1 to 1, x with respect to x. Okay, we have x squared over 2 from negative 1 to 1, which is 1 over 2 minus 1 over 2, which is equal to 0. Okay, that's why this one is equal to 0. Okay, good. This will be applied to our Fourier cosine and Fourier cosine and Fourier sine series. Okay, if f is an even function, okay, on the interval negative L to L, then a naught is equal to this one, 2 over L, from 0 to L fx with respect to x, and an is equal to this. We will be using here 2 over L, okay, because 0 to L. And then Bn is equal to 0. Okay. Take note here. Should be something like this. This one is from negative L to L. But this one is from 0 to L. Okay. So the definition, the Fourier cosine series is defined as such. Fx is equal to a naught over 2 plus summation n from 1 to infinity an cos n pi x over L. The reason behind this over 2 over L to over L, because as I've shown earlier, okay, cos is an even function, okay, sine is an odd function. Okay, next, if f is even, it will be as such, okay, and f is odd, the integral for fx from negative a to a with respect to s is equal to 0. That's why here, since sine is an odd function, okay, this one is even. Okay, even, that's why we have this. Okay, even times even is even function. Okay, let me write it. Okay, this one is actually even. This one is even times even. So we have even. That's why we have this one. Okay, and then this one is even times odd. It will be an odd function. That's why it is 0. Okay, so this will be the Fourier cosine series. Okay, where a naught is equal to this and an is equal to this. Okay, next is B. If f is an odd function, okay, f is an odd function on the interval negative L to L, then a naught equal to 0, an equal to 0. Why? The reason behind it is because a naught is an odd function. Remember, integrate negative L over L fx dx is equal to 0 because fx is odd function. Okay, next, an is equal to 0. 2 is because integrate negative L to L fx cos n pi x over L dx is equal to 0 because here fx is odd, multiply with even would be equal to odd. That's why it is 0. Okay, this one odd equal to 0 too. But here we have bn is fx times sin n pi x, because this one is actually even times, odd times odd, and that would be equal to even. That's why we apply the formula for even function. Okay, so the definition for the Fourier sine series is defined as such. Okay, that means a0 equal to 0, an equal to 0. We have fx equal to summation n from 1 to infinity bn sin n pi x over L, where bn is this. Okay, that's all for this video. We'll look at example on the even and odd function in the other videos. Okay, thank you class. Assalamualaikum.